Hey guys, so I'm actually going to be doing the creeping crust activity that your teacher should have sent you. That's going to go along with our discussion and the videos and the virtual field trip of volcanoes. And so I'm going to be reading this text. It's called Volcano Trackers, and then it kind of explains what's inside a volcano a little bit. So I'm gonna go ahead and read that, and then I will jump right into the investigative part with the experiment. So volcano trackers. Scientists are developing new ways to tell when a volcano is about to blow. Boom! Lava bursts high in the air before flowing in hot red rivers down the mountain. Hot ash shoots into the atmosphere, covering an entire continent like a giant cloud. Thousands of people flee their homes towards safety. When a volcano suddenly comes to life, watch out. Scientists want to learn how to tell when an eruption may be brewing. They hope to develop better warning systems so people can be prepared for the next big boom. Volcanoes do give some warning signs before they erupt, but in the past, these signs have been hard to measure. That's because working near volcanoes is extremely dangerous, and scientists couldn't get close enough. Now, new technology is helping scientists study volcanoes from far away. High-tech instruments placed near cracks in the Earth's crust can make gases or can sense gases that could mean magma is moving underground. Before an eruption, the crust can rise a little, like a balloon filling with air. Scientists have placed devices on the rocks to detect these movements. They're also measuring vibrations that pulse throughout the crust during earthquakes, which are often the first sign that a volcano is coming alive. Information from these sensors gives scientists a clearer picture of how volcanoes behave. Over time, it may help them figure out which volcano could blow next. Okay, so then it says inside a volcano. What gives a volcano its fiery force? Follow these steps to find out. Okay, and then it has these numbers 1 through 4 at the top. It says 1. Under the soil is a solid layer of rock called the crust. Under the crust is the mantle, a layer of hot, melted rock. The melted rock itself is called magma. So you have crust, and then you have the mantle, which is made up of magma. And that is shown as 1 and 2 down here on the bottom. Then we have 2. In some places, magma rises from the mantle into the crust. It collects in a magma chamber. As more and more magma rises, the pressure builds. The pressure gets so high, the magma can crack the rock around it. And that is shown, or sorry, that was 1 was the first one, I'm sorry. Here's 2, where that magma comes through. So all of this is the crust, but then that magma comes through right here. 3, the pressure pushes magma up through the central vent of a volcano. Well, this part where the mountain or the volcano is starting to go up, that is that vent. And 4, the volcano erupts. Once magma is outside the volcano, it is called lava. The eruption may also include hot ash, rocks, and steam, because all those things happen when it's hot. So here's the eruption, and from this point, all the way from here up, this has been magma. When it comes out, that's when it becomes lava, okay? All right, so I'm gonna switch over here and I'm gonna start doing the creeping crust activity with you guys, so bear with me. Okay guys, I'm back. So the materials you're gonna need for this are a plastic spoon, some wax paper, some whipped cream, half a graham cracker, and then the data sheet that your teacher should have provided. So I'm just gonna follow those instructions step by step. It says, where do volcanoes come from? Model how tectonic plates move to find out. So it says step 1, put a heaping tablespoon of whipped cream on a sheet of wax paper. So I'm going to get a big tablespoon here. Kind of looks like ice cream because it's still a little bit frozen. We're gonna see what I can do though. Okay, so then it says use your spoon to spread the whipped cream into a square the size of half a graham cracker. Okay, so I'm gonna do that now. Again, mine's still a little bit frozen, so I would definitely suggest making sure that it's not frozen. Not a complete square, but close enough. Okay, and as long as my wax paper stays, I kind of had to tape it down a little bit on the corners. Okay. All right, so then it says use your spoon to spread the whipped cream into a square. And this is to show the model of the Earth's mantle. And remember, we have the crust is the outer layer, and then the mantle comes next. Okay, the whipped cream is the melted rock or the magma. Okay, and remember, while it's underground, it's still magma. It's not lava until it erupts. Okay, so then it says the half graham cracker is going to be your solid rock crust. So that's what this is going to be. It says carefully break the cracker along the line. So I have taken it and I've broken it once. This was the full one. I broke it in half. Then, this is very tricky. I always struggle with this when we're making s'mores. Breaking that cracker in half along the line. So I have 2 even pieces. Okay, it says place the 2 pieces next to each other on top of the whipped cream. Their broken edges should touch. Okay, so I'm gonna take that first piece. I'm gonna kind of put it on there good. My second piece, and the broken edges should touch, so it matches up pretty good. Okay, now it says each piece is a tectonic plate. The place where the 2 broken pieces match up, which is here, is the boundary. The plates don't stay still. They move slowly. You will model 3 ways that they can move. Okay, so along this boundary, these plates are going to move different ways around each other. All right, so the first one is a transform boundary. I'm going to slide the crackers past one another like passing trains on an opposite track, or trains on opposite tracks. Okay, so the example it shows me is this one. So I'm going to model them pushing back and forth as if they were 2 cars or trains passing each other. Okay, so I'm going to move them back and forth, back and forth. I'm gonna do it a few times. Okay, now I tried to keep them together. Okay, it says, can you feel them rubbing together? How much magma or whipped cream do you see between them? Well, I'm gonna kind of hold it up so you guys can see. Whoop, I'm losing my paper. There's magma in between that boundary there, okay? All right. The second one is a divergent boundary. It says carefully move the crackers back into place, which I've already done. Then slowly push the crackers away from one another. So think diverge or go away from each other. This causes a rift or a separation of plates. Okay, so the example of that is here. So I'm gonna just move them away from each other, okay? Okay, so here we go. Moving them away. So you can see there's a nice little gap there. It says, how much magma do you see between the crackers? Well, I see quite a bit of magma. Real magma would harden into new crust. So when this happens, it pulls it away and that magma kind of fills in the space and hardens to make crust again. Okay, now it's telling me to put the crackers side by side again. Cold. Okay, this third one and last one is going to be a convergent boundary. It says push them toward one another. Let one cracker slide underneath the other. How much magma do you see between the crackers? Okay, and here is the example of that one. So I'm going to move them towards each other. Okay, so essentially I'm going to make them do this. One's going to be on top. Okay. So I'm gonna turn it this way. Okay. Ooh. Okay. Let me hold that up for you to see. That is our convergent boundary. Okay. Now it says when Earth's plates do this, the lower plate, which would be this one down here, melts into the hot mantle. It becomes new magma, okay? So we've learned that when they separate that extra space in the bottom, so when they diverge that space, that magma creates a new crust. But when one plate slides under the other, this one stays a crust, but this one melts and becomes new magma. So it kind of repeats the whole process. Okay, now I'm gonna put them back the way they were to start. And you'll see that there's some magma or whipped cream between those at that boundary. That's fine. And finally, step 7 says, think. Volcanoes can form where magma rises through the crust. Hence, right here at this boundary, it came up. You just modeled 3 different ways that can happen at boundaries. Think about which ones brought magma close to the surface. Which kinds of boundaries seem best for making volcanoes? And that's the question I'm going to leave you with, and make sure you answer on your response sheet. I hope you guys enjoyed this. See you later. Bye.